Yulia Sion. I'm a researcher and industry expert in haptics and wearable technology, and I will be hosting today's episode. Today, we will talk about the evolution and new horizons for haptic technology. Today, my guest is Dr. Ali Israr. He is an engineer and researcher specializing in haptics and sensory feedback at ByteDance company located in Seattle. His work and research focuses on using touch feedback technologies for various applications, including entertainment, education, therapy, virtual reality, you name it. Prior to ByteDance, Dr. Israr led haptics research at Meta Reality Labs and Disney Research. Hello, Ali. Thank you so much for finding time to chat with me. I'm very, very happy that this finally happened.
Thank you, Julia, and thank you for inviting me, giving this opportunity to talk to you as well as your audience.
Thank you, because I will start with a personal disclaimer. I would love that because I encountered your research in my first year of PhD, and since then I followed you, and you were one of the first authors I cited, and you were very open to answer my questions from like unknown students, and I was very amazed by that. And since then I follow your career, and it's been amazing because you are not just a researcher or just an engineer in haptics or just a person who works in a company to do like products in haptics. No, you're actually a combination of everything, which is very, very impressive. And you have a very long career in haptics, right? Just in haptics, encompassing all kinds of different directions within haptic technology. So it's very, very impressive. And I want to ask you this question. I always ask this question. I start the conversation about asking our speakers to talk about their career path. And I want to ask you the same. How did you get into haptics? But most importantly, why did you stay so long? Because you might as well change careers.
Yeah,
What kept you going?
thanks for this question. And as you said, I've been in haptics for a long time and doing both the academic as well as the industrial side of haptics. So to start with, my background is in mechanical engineering, and I started working in haptics during my PhD at Purdue. And at that time, the goal was to understand the communication capabilities with haptics, specifically how the broadband information that could be derived from speech signal can be communicated through touch. And mode of haptic that we were using were more vibration. They were mechanical in nature. So they were very much related to what I wanted to do, understand the human systems, the control system, as well as the systems in general behave under different mechanical inputs, whether they are vibration or they are forces. So rather than using artificial system, it was more about like understanding human. So it was very interesting. But at the same time, we wanted to artificially create these systems that could communicate this haptic information. But now the haptic information, what we were interested at the time was something that could be derived from speech. And there were several questions that, if you look at the speech is a very broadband information, and throughput is very high. So the question came that if touch has the capacity and equity to cater such high information throughput, or even if the touch feedback is processed and comprehended the same way users process or comprehend the speech and audio signals. So the main thrust was to understand how the information in the physical world is processed in the cognitive world, and how users will process it and kind of get any output. So it was kind of a mechanical system, but there were a lot of human factors involved in it. So it kind of attracted my attention. And back at the time, the cell phones were
Specifically, the human aspect of that, right?
there was a human aspect of that was very interesting to understand the cognitive and brain processes, how the information could be processed, the mechanical information. I was very new at that time, but although at that time, there were no cell phones, there were no iPads, but there were cell phones, but you could only use it for text messages or phone calls.
Mm-hmm.
There was no smartphones at the time, and it was really exciting at the time to think about, oh, we could digitally communicate touch through this internet. So it kind of became a very exciting opportunity. And the problem that we were solving, that there was so much information outside, can we communicate it through an alternate medium? So this is what my inlet to the haptics, mostly understanding the primitives in haptics as well as the psychophysics behind haptics, how we can,
Mhm.
what is the psychophysics, how we can use it to design different devices, hardware or different processes with humans in the loop. So
And what
after
kept you going?
it kept me going. It was very exciting, and we were successful at least at finishing my dissertation at that time. So right after that, I joined Rice University as as a postdoc, where I extended my tactile and haptic input capabilities and started investigating correlation between motor activities and haptic feedback. Especially we performed a lot of psychophysics to correlate human manual actions or manual tasks with haptic feedback. Or if
Can you
the
give an example of that, like manual example of manual tasks?
Yeah, so for example, when we are doing any manipulation of object or any type of manual task, so we use our hands a lot. So there's a lot of information that is coming from our hands, but at the same time, there is a motor component that our brain is asking our hands to move in a certain fashion, depending on the feedback that is coming back through our fingers. We have a visual information or the other sensory information, but with the touch information, how does this whole loop works? Back at the time, we were reading about like that the motor action. So rather than this motor actions, when people are doing motor actions, rather that information coming all the way to the central nervous system or to the brain, there were
Mhm.
local loops that would close the system, and the haptic was a very strong component. So we wanted to understand, in what scenarios it would work, how we could design better devices, what the specs would be. So a lot of psychophysics was involved, kind of closing their haptic
Mhm.
sensory motor loop. But at the same time, I was also interested if haptic could be used to regulate human movements. So, for example, can haptics could be used to regulate breathing patterns in users, because
Mhm.
breathing patterns are directly related to stress. So if haptics has a certain impact or
More
certain
like related already to well-being and some sort of like emotional regulation, possibly, right?
At that time, I was not thinking about emotion regulations, although later in my career, we found out there is a strong component that haptic could be utilized. But back during my postdoc days, we were thinking more about if somebody needs to maintain a breathing pattern. So rather than providing breathe in, breathe out information, can we have some type of haptic cue that could guide them
Mhm.
to regulate their breathing pattern? So something that people can wear on the arm or on the chest, which is very close to the breathing instruments in the body, it has a direct correlation. As well as there's a lot of motor activities when we are talking. So this is also our vocal tract is moving. So can the haptic could be used to detect and process that information? Can we
Mhm.
actually provide that information through the skin, and can the skin process it much better? So this was a great time for me to understand the perception and feedback loop, as I mentioned, these sensory action loops associated with touch. But this was mostly in the academic realm. It was a postdoc with Rice, a lot of talented people over there, and the technology was in a very, very primitive stage. So after this postdoc, I joined Disney, and Disney was a great place for my personal growth. Provided a good transition from academic research to the industrial research. Plus, they have whole playground in the parks or in other business units that they were involved with.
Mhm.
And at that time, my focus extended from psychophysics to building new hardware technologies. And here I worked with a lot of talented people and a very talented team led by Ivan Poperev. And we built several devices. Just to name a few, we built electro vibration based device for touch surfaces we call at that time Tesla Touch. Although at that time I didn't know there was a Tesla as a company, but
Yeah.
Tesla Touch was a pretty cool
You also
name.
have to suit, which is also different thing.
Exactly. We also investigated in how we can create free air haptics, so somebody that users do not have to instrument any haptic device on the body, because haptic is very proximal feedback. You have to touch to feel something. It's not distal like vision. Vision is distal, audio is distal. You can see it from far away, but touch, you have to physically get close. It's proximal feedback. So we were looking into making these free air haptic to kind of like, instrument them in the environment rather than on a user. And also we investigated
Like
multi-channel.
environment, like what? Like furniture or walls or.
Exactly, like, it could be a part of a computer, something like, on a computer, or it could be part of your desktop. It could be furniture, or it could be an architecture. It could be interior of a car as well. Like, the dashboard,
Mhm.
like, there's a lot of interactions that's happening inside the car. So in fact, I think recently there is another company that is looking into providing haptic feedback for the dashboard interaction. So we were also looking at that time, like, if there's a way we can create meaningful haptic information. And other set of devices that we started looking into is these multi-channel, multimodal surround haptics technologies that we can use in variable, holdable architectures and furnitures. So the basic idea was that we can use a sparse set of haptic units, but then using algorithms and illusions to create the feeling that things are continuous, high definition, and they are moving around a user. So that's what
Mhm.
with the name of surround haptics, that it's surrounding the user and it's not at one point, it's moving across in the space.
But it's also the type of sensation it provides. Doesn't have to be necessarily around, right? But somehow on the body, right? Or what do you mean around, completely around?
So haptics is a body sensation. So for example, when we are designing something for a visual system or visual display, we target eyes. It's very much like, the on the head, or ears. It's also like, on the ear. You can create the surround by manipulating the signals going into the speakers or into the display. So haptics, you have about 2 meters square of surface area to work with. It's not only hands that you have to target, you have your whole body. The back could be a very good canvas to kind of like, create or author any story that you want to present to users. So this was the main idea. It was Disney. It was kind of like, we wanted to create this sensory experiences.
So you
So
were actually exploring different body parts that could be so-called utilized for applying this haptic feedback, right?
Exactly, like, there were different.
Mhm.
So we made several devices, but the main concept was very similar. That there are these, like, these inexpensive haptic actuators that we don't have to, like, So in the visual display, like, we always we talk about pixels and what is the resolution of the display. And now, like,
Mhm.
there might be, like, hundreds of thousands of pixels, like, in a display, but putting this many haptic units on the body, it will become very, very heavy. So
Mhm.
can we reduce this complexity in the device technology, but use the software and algorithms to create this high definition haptic experience around user body or on user body? So this was kind of like, a really interesting way to look into haptics, and the technology was quite mature. So what we were able to do at that time, we were able to push some of these technologies into product space and experience this end-to-end research to product transfer pipeline, where we built this gaming chair consisted of 12 haptic units that people could buy from Walmart at the time, and also worked on a ride seat with the 15 haptic actuators, which is later deployed in Disney World in Florida. So this was great, like, that we were building technology. But during that time, we also realized that building technologies is great, but without content and infrastructure to move haptic content from one unit to another unit, these will not be easily spread and applied to different application or mass use cases. So after, like, working on this hardware technology, we started my team started building these software authoring frameworks. And at that time
So
we
it's
came
still in Disney, right?
this was still in Disney. Uh,
Mhm.
so we came up with these concepts of field effects or haptic animation tools or fieldcraft or stereo haptics plugins that use these established frameworks, which were already common in audiovisual domain to
For
cater.
example, like what? Can you give an example of
So for
such
example,
thing?
So haptic animation is more like, you're creating a visual animation. So visual animation, you might have a After Effect or other type of a tool that
Mhm.
you're taking a certain object, and you're creating a pattern to how this thing will move in the
So
space.
it's like an editor, basically, like so sort of like an editor, right? Like visual editor, but in this case, like haptic editor, right?
It was more like a haptic editor, but rather than
Mhm.
changing the waveforms, you could change the waveform. But the basic idea was like, we were going into the spatial information. It's not a
Mhm.
single actuator. Don't need to design for single actuator, but if you can design this animation pattern, and the algorithms will automatically convert this animation into the signals, and then the signals could be used to drive this hardware technology that would recreate this pattern. But the main idea for building this tool was to reduce the adoption time, because most of the workforce did not know haptics. They don't know what the particularity of the hardware technologies are. So we wanted to make tools that could be adopted by this workforce who are actually working and building the
Mhm.
content, the story for the ride, so they can use and build the content rather than like, the researchers or people who are only good in haptics. So that was the main reason that like, we took this approach. So after Disney, I moved to Facebook. Particularly, there was a concept back then called Building 8. And in
Mhm.
Building 8, I led projects Hearing with Skin and Social Touch, with primary focus on building new hardware technologies. There, I had an opportunity to work in Michael Abroch's organization up in Seattle. So I moved to up in Seattle, and this provided a great opportunity for me. I worked directly with many brilliant people in a variety of cross-functional team, and I felt that my career grew and matured with a very clear picture and of challenges and opportunities in haptic during that time.
Mhm.
Uh, so from Meta, a couple of years ago, I joined ByteDance. Here, I lead a team in US and China. I also increased my scope from haptic feedback to also include haptic sensing, neural
Mhm.
sensing, and biosensing, and put all of them together in a single ecosystem. And currently leading both research and advanced development towards product spaces.
Yeah, when you say haptic sensing, what do you mean by that? Just to make sure it's clear to.
It's an inverse of a feedback. So feedback is like,
Mhm.
that the information that we created with the artificial device that people are feeling. But in the real life, people are already feeling these haptics. So if we understand like, what people are feeling from the haptic perspective, this is what haptic sensing is. So for example, the movement of a body, that is the haptic sensing. The haptic has both tactile and kinesthetic. So if the kinesthetic, there is any movement or any force that the human is applying, we also need to capture what forces that people feel. Can we capture those forces?
In
So we
real life situation, basically, it's about already real tactile sense, right? So basically, you're trying to get into this fundamental understanding of how we sense through skin, basically, right? And
ex-
also kinesthetic approach, also kinesthetics.
exactly. And if you think from like, the feedback is like, okay, there's an analogy between like, speaker and microphone. Speaker displays
Mhm.
the information, microphone captures the information, but these are both in the haptic domain. Sorry, in the audio domain. So do we have a similar thing in haptics? So a speaker is kind of like this actuators or transducers that are creating that information, but microphone is capturing that information. So do we also have these devices or systems that we can capture the haptic information that we can further process and then we utilize in creating content with our devices? So for
Mhm.
example, like, the camera system or the microphones, these are very common in creating a lot of information for the visual displays or for the audio displays. So for example, I can record a music, I can record a song, and then I can play it back through my speaker. So there is a whole loop. So in
Mhm.
haptics, we also want to have something very similar where we can capture the haptics and then we can reproduce the haptics. So there are two systems, and then in the middle, there is some type of an engine that is processing that input information to create an
Mhm.
output information. So
That's
that's what, like,
super interesting.
This is very exciting. This is a very challenging space, and I see a lot of growth and contest in
Are
this
there
market.
any off-the-shelf technologies that can sense haptics at the moment, or they're all experimental?
No, in fact, there are a lot of technologies that are there, and they have been used in products as well as in the field of robotics. In fact, they might not be considered as a haptic sensing, and this might be the term I will be using. But if I see the correlation between the feedback and the input, there is a very strong relationship between them. But let me give
Mhm.
you an example. An IMU is a very good example of it detects human movement. So, okay, so I'm moving, my IMUs can detect where I'm moving. So it
Mhm.
is kind of like a haptic sensor. Same thing with the tactile sensors, soft pads that or pressure pads that if you press on something it gives you the distribution of the pressure.
Mhm.
So,
Mhm.
which is used in a lot of robotics, a lot of training purposes. Internally, those are haptic input technologies.
Mhm.
It's just they were used in applications
In a
where
different ways. Mhm.
very, very different. The problem is some of those technologies are really, really expensive. So can we actually reduce the cost and make them very abundant? So this is
Mhm.
target. Can we build these technologies that can detect my tactile input, my contact input, my movement, my force output that we can use to further train our system or can be used to
Mhm.
use for different
So like a
purposes.
combined system together, right?
Exactly.
Mhm.
So sorry,
Well,
this
it's
little bit a long description of my career, but this is where I am in my career.
well, it has to be long, and it's actually been very short in comparison to what you've done. So you tried really to make it so concise, but thank you really much for your overview and also in-depth kind of details. You mentioned a lot in your descriptions of projects you did in different areas, right, and companies. And a lot you talked about this information throughput, right, the bandwidth of communication, the kind of communicating the meaning. Can we communicate the meaning, or how much of this meaning, or how meaningful is that meaning, right, that we can convey through haptics? So all this comes to kind of a question in terms of haptic language, right? And it's possible probably kind of roughly to categorize haptic feedback. Like there are two different ways to create haptic feedback, right? Roughly. One would be maybe rendering real touch sensations. Let's say, I don't know, tap on a shoulder or caress, right? For instance, using some algorithms. One of those you also developed together with Ivan Poporyov, right? Tactile brush. I remember myself recreating it in my first year of PhD. Or another way to create feedback or meaning through haptics would be creating these haptic icons, right? Some sort of short bursts of information that would map to a specific meaning, right? So
Mm.
now the question is from your breadth of your variety of experiences, what are the most, I would say, successful, maybe promising techniques or most appropriate techniques
Mm.
depending on the context of use for creating this haptic language, and maybe where do we see the most potential, and maybe where do we have a knowledge gap still, right?
Mm. And
In terms of haptic language per se.
I'm pretty sure a lot of people working in this area, they might have their own views. So I'm just going to say what my view is.
Of course, and that's your experience.
So in my view, they all are important. And as you mentioned, it depends on the context and the technology that you're using. For example, you mentioned about these tectons or haptic icons. They are actually pretty good for building blocks for libraries such as for notification or providing these single unit input. Like they have
Mhm.
all capabilities. Tactile brush algorithms, they cater these fast set of actuators, specially distributed actuators, and that's where the algorithms would work. So it depends on which technology or what is the context where you are working on. These would different technique would work. But
But it's also a question of like, can do we have to like really brush upon or try to make it ideal in terms of rendering real touch sensation, or we better create a new set of sensations, let's say, that will work much better than us trying to recreate real touch sensations?
I think so. So from the real touch, like, even if you go like, in the visual domain, like, people were not creating at the beginning of the camera technology or the sensor technology. People were not getting all the information from
Mhm.
the environment. They used to be black and whites. They used to be like, very bad features were captured or displayed at the time in the movies. Also, like, animation does not look real at all, but they have expressions, they are believable, and they could communicate a lot of information to users as well. So I don't think that being realistic is as much as important as being believable and being understandable. If something like, if you want to convey an information, and if the other person could understand that information, whether it's realistic or not, it could work. The only problem is like, when we talk about realistic, it means it's coming from the natural way, and people already have these cognitive models inside our brain
Mhm.
that we can quickly like, connect. Okay, this is what it means. So for example, if I touch a fruit, which is like, and usually I use touch to feel like, what is the inside of the fruit, whether it's a rotten or whether it's a fresh, or sometimes like, I can use my haptics to understand the state of a fruit. I have realistic model to understand like, that what this is, but I can also learn an alternate process where like, this information could be conveyed to me as long as it's believable. Like, I would
Mhm.
go with that.
Yeah, interesting concept, but believable, right? How do you make it believable? Like, and it's related to this kind of current knowledge gaps and like potential where what is missing still to make haptics more believable, more expressive and more meaningful, right? Given the limitations, of course, of hardware and our own sensory system.
And this comes back to like, the initial question of like, there's a lot of information throughput. What is the capability of the device that can provide that information? The first level is, okay, what is the extent of the information that could be communicated with the device? If the device cannot provide certain information, for example, if the device can only play two dots with two colors, so you have a limited information capacity of that device. So like, whatever you're going to use that information, it will have a limitation as well. So the first thing is like, when you're creating a device, does it have a capabilities to provide that breadth of information? And once you pass that step, then the second step is, okay, how the brain is going to process it. And there are a lot of theories, a lot of different ways, like, we understand construction of these haptic signals. We want to produce a very natural feedback, but sometimes, like, there are no rules, or the device might not have capability. So one of the technique that we usually use is what we call cross-sensory correspondence. Something like, that we all have already created models in a different sense, and then like, can we use the similar models with haptics or with the vibration, because vibration is not natural. I think if you think about it, the vibration vocabulary in nature is very limited. There's a force feedback, there's something like, drawing on the skin. They are not vibration in nature. But can we use the vibration to create the similar or same experience that people can learn quickly? So there is
Can you
this
give an example of these cross-sensory mappings, kind of?
in order to get people's attention, usually people basically tap, and like,
Mhm.
and then like, the tempo of this tap dictate how much attention needs to put on it. So for example, if we have just a single tap, it might actually have a different meaning. But if I continuously tap myself, it means somebody needs my attention quickly. So I took this example from tapping, which is a haptic in nature, but once we created with the vibrations, which is a total different modality. But if you think about it, like, in the visual and audio domain, we have already built these internal models. For example, when the ambulance or the siren comes, it's always like, with certain period, a certain frequency that they
Mhm.
come. We know like, okay, there's some type of emergency, so like, we have to take some actions. Same way is like, when some light is blinking, like, there could be just a notification or something, like, when they really need people's attention, they just increase the pace of that light flicker. And all of a sudden we know that, okay, because the variation is very fast, so it means like, that the emergency level or the attention level needs to be
Mhm.
much higher in this case. So now these are more cognitive in nature rather than, yeah, our device could deliver these type of feedback, but now how we can use it to construct our language, then it becomes kind of like, another art, I would say.
And that's more like a try and error, or are there any standards?
I think currently this is more about, because there's a lot of active research is happening in this direction, how we can take this haptic feedback coming from a device, and how we can correlate to a meaning or library, and how we can use it for storytelling or kind of like, communicating with the user. The first level is like, you have a hardware and you construct this primitive or building blocks for haptics, and now you take this building blocks and can you actually create the meaning out of these building blocks. And in this case, like, you can take a lot of information from other modality, because it's much easier for people to understand. The also another thing is, when we are in a multisensory environment, there's other information that kind of comes and cater the context. So the context could be provided with some other sensory information that we already understand, and haptics is only there to close the loop quickly, and people can learn the context and the reason for this haptic very, very quickly once there is a multisensory information available.
So in fact, you were talking about metaphors, right? So we could use some sort of metaphor-based design for haptics, right? So let's say there is a comparison to the ambulance or someone walking fast, maybe then it means in a rush, right? So some object moving fast, let's say visually, would probably mean higher frequency vibration, and that would mean something, I don't know, a busy space, for instance, or things like that. So it's kind of this type of things, right? So we take one concept from one modality and try to map it metaphorically in a way to haptic feedback. Am I understanding this correctly? I'm just also trying to clarify it for
Well,
audience.
this is a good way to look at it. Like, because one of the thing what we want to be careful about it, or what we want from haptic feedback, is that it's useful. It could be understood by multiple users. We don't want to train them. And you can train people like, with, and say like, this vibration means this, or this vibration means this. But like, there's a lot of cognitive process that will happen to understand and learn this type of mapping. But what about if there are inherent systems? Our brain is already kind of like, understands whether it's a conscious or unconscious way that the brain understands. Can we exploit it? So let me give you an example. Like, when we started with the Facebook, with hearing with the skin, the main idea was like, there's a lot of information that we get from the speech and translate it into a person. So we could just randomly assign the vibrations to different phoneme or different alphabets. But what we found, if we correlate this haptic feedback to how the speech is constructed in our mouth, because we have been trained to talk ever since we are children. We so subconsciously our brain knows, if I want to create a certain sound, this is what I need to do to my vocal tract to create that part of a speech. It was a very similar idea, like, that there is and if you break down phonemes, there are three main components. One is the voicing, which is the main vibration. The other one is the place of articulation and the manner it has been articulated. So if we take the same information, like, the manner, the place, and voicing, and kind of map these things into a very natural way. So for example, the place of articulation, when I utter "b," it comes on the front of the mouth. Whether, like, when I say "ka," "ka" is produced in the back of the mouth. So if I take this mapping that already is in my brain and map it to "ba" comes on the front of the hand, my forearm, and "ka" comes on the back of the forearm, will that be a much better approach? In fact, actually, we did some studies and we found, like, within like 60 minutes of training, people can obtain a vocabulary of about 100 words. So they can learn.
Interesting, just by manipulating the location, right? So it's a spatial kind of design in that sense, right?
Yep. And
Right.
because now the spatial design is highly correlated to how the speech is produced by a person. and they know how the speech is produced. Quite frankly,
And the
when
trigger, sorry, and the actual vibration was the same, right? It was the same. The only change was the location.
so because if we see like the phoneme, so we have a b and p. They are both constructed in the front, both are plosives, but one has a voicing, one has a unvoiced. So b, there's a voicing of a vocal tract also vibrate, but in p
Mhm.
it does not. So what we do the vibration, we use the lower frequency for b, which has a voicing, and a higher
Mhm.
frequency for p. So there's this distinction as well, like if we
I
want to
see.
communicate both the b and p, then like then the other parameters in haptic could play a role. Oh,
Mhm.
so
Okay.
so the learning was one challenge. Can people learn it? But the bigger challenge was, can if the stream of this haptic information coming to user, can they actually use it to construct words, construct sentences? Because that is what people are going to process. They're not going to process a single phoneme. They're going to process the whole word, or like the a whole sentence. Uh,
Mhm.
and some of our collaborators kind of like went out and kind of further did those studies, and then found out like that using the phoneme translation was actually a very effective in creating these speech to touch kind of like devices. Ended up doing some studies with normal people, some hearing impaired people, and they have published results. Quite frankly, I don't know on top of my head like what the results were, but they were promising.
Impressive, impressive. Well, just to kind of summarize this conversation, because I think it's very, very important on this haptic language, right, and techniques. So you mentioned about the building blocks, right? So can you just summarize in a sense, like what are the building blocks for creating or constructing haptic feedback or haptic language itself? Because when we say language, it implies some meaning behind, right?
Exactly. Like, you can think of building blocks as either phoneme of alphabets. We are not talking ABC, but we are using ABC to build these words, and words are building these sentences. So same thing, like, and the way the language is processed with the speech, we understand how when the building blocks are coupled together, like, what do they mean? And we can process it pretty quickly. Same thing with haptics. One thing, okay, we are using this modality from the hearing, like these are all verbal communication. So for example, looking at text or listening to somebody's speaking, they are very much the visual or the auditory modality specific. But
Mhm.
in haptics, we can use haptics to communicate that information. But the natural way for feeling haptics is this something that we feel, which is non-verbal. I would say like these are non-verbal. Yeah, like for example, the stiffness of an object or the smoothness of a surface. They don't communicate the same way as we are communicating right now. But there's some information that is hidden in them. So the building blocks are these primitive levels that we can use to construct this higher order information. A lot of people use different building blocks. If we go in a very, very low level, we can say like, building blocks could be this RGB of touch. Okay, what does it mean, the RGB of touch? In the visual system, we have this red, green, blue, and we can use this red, green, blue to construct like, the whole picture, the whole
Mhm.
paint, anything that we want to construct. But are there actually any primitive level dimensions in haptics that could be used as a building block, for example? And in this case, like we think like so there is a primitive haptic primitive such as the vibration, the pressure, the skin shear, the temperature. These are all primitive, and like whenever we feel the
Mhm.
real, it's a combination of all these haptic primitives. So this is a very low level of like what the building blocks could be. But one like who's build video game, or who's writing a story, and they want to use haptics, their building blocks will be one level above them. Okay, so we use RGB, but with the RGB we created these text alphabets which looks like A, B, C, or which like from the device technology, it's some very basic primitive, and then once we go into the language or to content, then we use this ABC, or in sometimes like we have these primitives as a box, like in Unity. if you're building this 3D environment, they don't give you all the shapes. They give you like, this primitive such as a box, a oval, or like, these shapes. So these are the primitive shapes which will be useful to construct the next phase of things that we want to construct. And it could be very dependent on what we are trying to build. So for example, in one of our study, we built this building blocks to convey storytelling. And in this case, we know like, in a lot of storytelling, there will be something like, that will be moving left to right. Okay.
Mhm.
So now if we have a building block of this movement, so now, and the parameters we can use to control this movement are the thickness of the movement, the speed of the movement, the location of the movement. And now if we have this primitive, this building block, and we can control these parameters, then we can construct a handful of different experiences, whether there's a snake, whether there's a mouse, whether there's a hamster that is moving on the body, or whether there is like, something which is like a wind, or something else that actually interacts with the body, whether it's happening on the back or it's happening
Mhm.
on the forearm. But our building block is the same, this movement, or kind of like, this tactile brush. This becomes our building block, but then
Mhm.
parameters become.
Changing the parameters, then it's really next level, right? And trying to figure out what is the sweet spot to achieve, to
So
map to that particular meaning that you.
Exactly. And building blocks is a complex concept. Like, there could be different type of building blocks for different modalities or different application. Uh,
Mhm.
for any designing software, they already provide some way these building blocks to construct the experience. In haptics, like I think this is still in mostly in the research, like what would be the ideal building blocks that could be used in all scenarios, in all situations.
Mhm.
This is still TBD. I think we can start with something like, depending on the technologies that are available, we can have those building blocks. But as the technology side grows, we can also construct more building blocks. But the important thing what I want to emphasize is like, technology itself is not sufficient. We need this building block capability as well. Think about it. You have a cell phone, but if you don't have any
Mhm.
application on it, like, you have iPhone and you don't have any application, would you buy an iPhone? Would you use an iPhone if it doesn't do anything except for like, just show lights? Uh, Same thing like, television, like, you buy television because there's a lot of content that is created that we use. So if the technology itself allow us to create a certain building block, but then there's a translation what the application is, it will also have its own constructs, and we have to define those constructs and then use them. So there's not a whole lot of repetition.
I think this topic goes well with my kind of other question about the design process, right? So we talk a lot about the building blocks. Will you be able to share with us like your best practices for your design process? How do you like start building things from scratch? Taking into consideration that haptics do not have that much of standardization like we have in visual interfaces, right? We don't really have many prototyping tools that are very much available to like practitioners. And maybe also reflect about this design process when you started your career in haptics and how it evolved. Maybe things got better, maybe we have better prototyping tools, maybe we have some standardization, I don't know. So what's your observation regarding that?
Yeah, this has always been a challenge. Like, being an engineer, I might not be the best person to create any content. It's a very artistic approach. People like, who works in arts, in design,
In
they,
haptics, is an artistic approach.
oh, in everything. Like, for example, like like as an engineer,
I
one.
actually can relate to this. I actually agree with you, but you're the first person who said that. So I'm like surprised because I feel that way too about haptics.
So as an engineer or as a person like, working in this technology, we could do, we could actually provide tools which will give people this freedom and power to create the content or the design based on their capacity or whatever they are thinking. And one of the biggest problem that what we faced while we were working with some gaming companies, they said like, I don't like this haptics. like, you're giving me this set of haptics, we don't like it. So initially when we started with haptics, we had this set of, like, well, we actually sat down and I programmed each one of them. And then we say, okay, this is a palette, this is library, and somebody will use it. And they say, oh, I don't like it. So what are
Mm-hmm.
the, how can I change them? I want to change the ending a little bit so that it doesn't feel like too vibratory. It feels like it's decaying and it matches with the story of this animal, like, that you're riding, that it has screamed. And like, I don't want to have this motorcycle feeling, whether I have to feel this organic feeling. So can I do this? So we started going into, okay, what are the tools that we can use that would
Mm-hmm.
cater this type of construction, this kind of, like, building material for storytelling.
That
So
was back in Disney, right? I assume.
Exactly. So we came up with this concept, like the technology is not the only fundamental issue. It's also the building blocks of the technology, how we define it, and how we construct the content. Because I'm not the one who can create a content. I'm an engineer. I can build technology, but content, it's not my game. So, but we have to empower people with tools that they can create content, they can edit content, and there needs to be a minimum level of transition from whatever tools that they are using to some tool that they are using with haptics. So this is the big problem with the gaming industry. Like, they don't want to have another tool for haptics. In fact, like, they, most of them actually use audio based tools which are already available, and they use
Mm-hmm.
them to create haptics. And the processes that they use is very much very similar to whatever they're using in the audio. What is the influence of a lower frequency versus the higher frequency? How the abrupt stoppage or onset of vibration feel like? What's the difference between abrupt and gradual increase in the intensity mean? So people use very similar ways to create these vibrotactile constructs, and it works. And this is a
Okay.
but there are a lot of other things which are coming from research that because haptics is not audio, like, it's not our auditory system is very different than haptics. Haptics is much broader than just the vibrotactile. There's also these forces, there's a temperature, all these things are part of this haptic system, but we don't have tools to generate all of them. So I've been thinking about, like, what would be the right way to actually construct this. And I was thinking about, like, there might be actually three different classes
Okay,
of
what are they?
this construction. One is, like, you basically have the content already in another medium, and then you do some translation. This is something we talked about, doing this cross-sensory correspondence.
Like an audio and mapping to haptics.
Exactly. So for example, there's a movie, there's a sound coming from the game, and, like, nobody wants to construct haptic for all these sounds. So what we can do is we can take this sound, or this audio, and we can process it. We can actually, like, lower the frequency content. We have the left and right, so we can have, like, left haptic plus right haptics. So that is preserved. But in terms of also, like, if the content in the sound is low frequency versus high frequency, for example, if it is a rumble, or if it is a background music, or it's a swoosh that comes in the game. So maybe the rumbles could be done on the seat of a chair, and this high frequency content could be on the upper back. So now
Mm-hmm.
there is these correlations that we define depending on the spectral features of the audio, and then we are doing the direct translation. And then, like, now we can construct, like, this auto generated auto translation from one modality to another, whether this could be some type of audio coming in, or it could be some type of a video feed where a ball is moving from left to right. We just track the ball, and then, like, we create the haptic
Right.
correspondingly.
So you're saying we don't need specialized prototyping tools for haptics. We can just utilize what we have now.
I think it depends on like, at what extent do you want to go. If you want to create a first level of haptic experience, this is fine. But if you want to go more and more complex, then you may actually need more and more tools. But the thing is like, those tools are not standard. There might be some tools available in specific companies. So for example, Meta released some type of haptic studio last year, and then there are and Haptic Lab. They also have tools to create these haptic experiences. So like, there are some tools, but the breadth of haptic, they don't cover the whole breadth of haptics. So this is one way, like, we can use the information and convert it into the haptic feeling. The other way we talked about, like, this record and play. You can record something and then you can play it with the device. If it doesn't feel right, you can adjust this level a little bit, and then kind of like, tune in, so in this case, you don't have to construct the haptic signal or take it from other, but you're recording it with some type of a sensor.
Right.
And the third one is like, which is becoming more common nowadays, is which would take this natural language prompt as input to deliver the required feedback. So it's kind of like similar to Chat GPT, but rather than outputting the text or images, it could output the haptic feedback. Although
Oh,
this is something like,
sounds great.
in this case, like, a person who has no experience with the haptics or any hardware technology, they can use their language to prompt the system and agent to create the haptic feedback for their device.
How far are we from this reality? I mean, do we have enough libraries for that?
So again, this is my view, and I'm pretty sure like, a lot of people who are working in companies or research labs, they might be actually thinking very similarly, or maybe they are constructing something, or they might have constructed something like, and we are not aware, or we might not actually saw it the same way. So there's some level, like, for example, the texture rendering, just to capture, like, if you have a certain video feed and you say, okay, I want to create a coarse texture, just input this information, and then it will create a coarse texture on top of that stuff. I think those things are already available. They just, like, did not put everything into a single perspective. They're like, okay, because like, and be the truth, like, before this Chat GPT, I don't know how many people actually thought about that they're prompting a system and system is giving them the output in the haptic modality. They might actually come up with a different approach, but now, like, this thing is becoming common, like, or already is very common. So this is something like, I think that we should invest and put some attention in building this type of a system, large language model for haptics, like,
So
uh,
like technical Chat GPT.
haptic Chat GPT, yeah, like, it could be haptic GPT or something, because the reason, like, you being a researcher, and you struggle, you might have struggled a lot in building the hardware first, and then building the software first, and
Yeah,
then
it
building
takes
the
a lot of
content
time.
first, and now using it in user studies. So can we actually streamline the whole process and make it a very, like, standard way, or very easy way for users to start using haptics? In fact, like, one of the project, like, we are driving right now, we call it Agent Hayward. So because there's so much information in haptics, and like, we don't know, like, so Hayward kind of like, puts everything together, and kind of like, can we actually use
Standardize, systematize it somehow.
standardize, or like, take that information that is out there and come up with a very streamlined process of using haptics in this very large information domain, and making life easier for users, so it can take the user prompt, or it can take the inputs from different sensors, but output the haptic feedback that is needed for that specific scenario.
So you believe such standardization, right, or systematization, whatever you call it, is possible for haptics, right? Because there is this notion, first of all, we don't have it yet, kind of readily available. There is notion that it's so much context dependent, and everyone has its own sensitivity and blah, blah, blah. So, but it seems like the standardization is still possible, right? We just need more information, I would say, or maybe something that can put this together in a more systemic way.
Exactly, as you mentioned, like, there's a lot of information, a lot of things are already there, but there's no standardized way to work in haptics. So the agent Hayward is kind of like, does this thing for us, that it's going to take all that information and put it under one umbrella. There's no reason not to use any published material which is already out there. There's no reason to reinventing the wheel if people already know how to create content with the vibration. Let's actually use that information that is already available in literature.
Mhm.
Uh,
Mhm.
Quite
Yeah.
frankly, whatever the haptic rules that, for example, like one company like Meta is using, it's very similar to what Apple is using for their Taptic engine. But because, like, there's no standard, they all are calling their own names or whatever this system is. And
Mhm.
underlying, this is the same process. They're using the same way to design haptics, to construct haptics. So might as well just regularize the whole process together, something that everybody can use.
I want to ask one important question, which was actually the topic of conversation about this evolution and kind of sort of future predictions for haptics, right? Because you've been working with like well-known researchers like Roberta Klatsky, Ivan Poporyov, Karen McLean, I mean, Hong Zitan, I mean, you name it, so many people, and you've tried so many different things. So looking at all that, like from top of your kind of career here, what do you observe in terms of evolution and how the haptics were developing, and what are the most like predictions for the future, and maybe what are you excited the most yourself, and what are your research kind of plans for haptics, where should the focus be?
This is a very good question, and kind of like, now again, it's my view. People may differ, they may actually look at differently. Being part of this industrial workforce, it's very important from my side to stay up to date with this evolving tech industry. Things change. There could be, like, different way. People start thinking of the technology differently when there's a new disruption comes. So for me, it's very important that haptic adapts to this evolutionary tech industry. So this is very, very important for me. I think from the haptic perspective, this sensory illusions in touch is very important to build core technologies, especially this, like we talked about this multi-channel, like tactile brush like illusion
Mhm.
that can move left and right. But there are these other illusions which are actually gaining a lot of interest, such as, for example, if I stretch my skin,
Mhm.
and if I have a device that stretches my skin, it gives me the feeling of pull and push, something that a kinesthetic device provides. But rather than having this bulky, grounded kinesthetic device, I can use something with the handheld object that is providing me the skin stretch. This gives me an illusion of pull push, or even the weight of an object, which have been,
Mhm.
like, used in robotics application with these big robots that could use it. But with illusions, we could actually construct them with certain clarity, certain believability. It might not
But
be.
is it possible to construct it as a wearable, like miniature device? So you said it's like only handheld device, or like what
Um,
kind of actuation technique would you use for that?
so for example, we did some work where we created this handle device, like a marker, like a pen. Yeah, it has a single unit that will stretch my thumb, and
Mhm.
it actually gives a very good indication of that you are, when you're pushing, it stretches the skin on other in the opposite direction. It gives you the feeling of this. There's a virtual wall in the middle of a room. This is amazing. But then there are a lot of other universities and scientists, like, they are making these variable, three-dimensional, these tactile devices that can stretch skin in X and Y direction, or even in the Z direction, which is the pressure. And can they
Mhm.
actually use these type of variables to construct this higher order, higher primitives in haptics? So I think this is really interesting direction. As you mentioned, what is the device? So there's a fundamental challenges in the core device hardware technologies, and this is something very exciting to me. And I think this will open another a way how we look at haptic devices or haptic feedback. And maybe like once we have these type of devices available, then RGB of touch would become actually much easier to implement. I think
Okay, so that's one way, right? So what other like exciting paths in
I
terms
think
of
still
evolution?
this multi-channel, this multimodal haptics, which closes the sensory motor loop. It's very important, especially when we are doing some interactions in the mid-air. If I touch something, if I don't feel it, quite frankly, I don't know if I have touched it unless I'm looking at it, and then it will take all my visual attention away from maybe my actual task. So some way of this, like, understanding this, how the multi-channel haptics would work and how it will work in these multimodal settings, and how the sensory motor loop is closed in various manipulation and control tasks, in manual tasks. This is very interesting, and I think this is very important to understand right now, especially like now back like 10, 15 years ago, we had a lot of devices like people would buy because it has a gaming or it has like some type of entertainment purposes.
Mhm.
But now there's a thrust of productivity devices, something like that is useful for everyday tasks or make life easier for people rather than an entertainment. So for this, we really need to understand this sensory motor control loop and apply those rules back into the hardware and software so that we can accelerate both the learning process and the execution process by using these novel technologies.
Interesting. So it's about new kind of compelling use cases, right? So you mentioned before it was entertainment, and I'm sure still it's a driving force, but now you also see the trend into more like functional devices, right? To
Efficiency, productivity, like
efficiency, productivity. What other application or compelling use cases you see would be in demand in terms of applying haptic feedback there?
I think, and this is again very
Or
personal
something that
about.
is interesting personally for you. I don't know, maybe like
um,
remote communication, because you have quite a bit of research on remote communication, or accessibility also. You have very interesting research.
something like I was really interested in like this non-verbal communication, and how it plays a very important role in our daily affairs. For example, human touch, it is very critical for human development, maintaining their behaviors, and
Mhm.
and like conveying a very deep innate thoughts between users. So artificial haptic, well, like I'm really interested in recreating this artificial haptics because I believe like it's not only supplement user interactions during texting, voice or video calls, games, and social network, but it also enhance our social presence and increase user engagement in shared digital medium.
Mhm.
So literally like where I started like about 20 years ago, that from we can digitally connect people or digitally communicate touch through internet.
Mhm.
I still am interested in kind of like taking that dream to a next level and making it more reality. So this is
What
something.
is missing? Is it about the reality of this touch, or is it something else? What else we need there? Because you already have like lots of research. Okay, we can like communicate some social cues or even emotions, but what else can we do? Like, how can we make it better?
I think so. So currently, like we have a very good context, very good like application. We have context, and we have like some way to kind of like recreate this experience. But at the end of the day, the feedback is not natural. Either it's based on vibration, or it's something like you're holding this big thing on the
Mhm.
hand, or like So yeah, like the technology might be there, or like they might be actually constructing something, but this little bit of like being slightly away from nature, it kind of like
Mhm.
breaks the whole illusion. So I want to reconstruct that illusion that there should be a least gap. I don't want people to hinder because they have to carry this big device to have this type of an experience, or they have to rely only on the vibrotactile feeling. Like, can there be more believable, more dimensions in touch in a very natural way for people to interact this object, this device,
Mhm.
and get that feeling back. Um,
So it's about exploring different actuation techniques, also form factor matters, right? Always.
it has a very complex problem. It has all the device issues, like, the throughput issues, whether it's comfortable or not, and then at the end of the day, and then, like, how we are going to construct the story around it. That is the second part, which is kind of like, also require a lot of attention,
Mhm.
a lot of processing. It needs to solve many challenges, but I think this is still a doable thing. And this is something, like, that really excites me, that if I we could create this feeling of some friend very far away, but we can have much more close innate connection with them. uh,
Mhm.
I,
Or maybe
I
no need anymore to be in the same space.
back and something like, 3 years ago, 4 years ago, it actually became really apparent that this is exactly what we need. When there was social distancing, when they were like, people were stuck in their house, they were
Mhm. Yeah.
touch deprivation, all these concepts were coming. We, like, people try to create this haptic feeling, and, like, and in some level it worked. But there are fundamental challenges in the technology, that maybe the technology was really not mature at the time. But, like,
Mhm.
at the time, people were able to see, like, okay, this whole deprivation could be reduced by these artificial technology, these display technologies. And can we actually go on one step ab beyond that and say, like, can we actually make it very consistent and very acceptable, that people do accept it? Like, this is, if, for example, if I'm wearing a glove, like, let's suppose
Mhm.
a haptic glove, and it makes me feel like, I'm holding a hand,
Mhm.
but it, like, which is, like, pretty far away in the world. I think this could be, like, very important feedback for me. The more important question is, like, can it capture the true intent or the true feeling of a person who's far away, and reproduce that at my end, and do the same thing from me
Mhm.
to that person? I think this two-way communication, that is also very, very important.
It is very interesting and important, I think, topic to investigate further. For example, in my like one of the latest studies, we kind of recreated this social support during a stressful situation, like public speaking, and we had a speaker and a supporter, right? So we kind of identified when the supporter also decides to send such social support, right? Through haptic feedback, and how the receiver reacts. And the reaction very much depends not only on the context, let's say on the like moments of the public speaking, because some peaks, some moments are more stressful than others, but also on the relationship between people, right? Which means a lot. So relationship really dictates how the meaning is interpreted. Yeah,
In,
so
in fact,
there are
like,
so many different elements that need to be considered.
in one of our studies, like, we actually observed that a shared context, actually, it plays a really big role in this device mediated social touch. Um,
Mhm.
in fact, in one of the case, like, we ask a person to create a haptic pattern on a display, and then we use the haptic animation to render it on their hand. And
Mhm.
and we ask them just arbitrarily create a message, and this person, like, created two lines and a circle with a certain
Mhm.
speed. So as soon as their partner, they actually felt that, they said, oh, she's saying, oh my God, because this is
Oh.
exactly the pace, and, like, there was so much correlation between the
Mhm.
haptic and the
Mhm.
audio way that they communicated, that this shared context actually had so much stronger connection to understanding what the person is trying to convey. So having this whole knowledge, like, we already have these relationships and some history with those relationships. So those information could be conveyed through haptics in a much more meaningful way. And so coming
Yeah,
back to your response, like, the shared context is very, very important to create
I
this.
feel like we are missing this more. We need more research per each context, right? So like nuances of each context, like it's important to observe how the haptic feedback is perceived within specific context. So in a naturalistic way, not in a lab, because at least in a semi-controlled environment, because
No,
that
mm.
changes a lot actually. Also.
The lab has a very strict conditions, like, you cannot get very natural response in the lab. But in other scenarios, yes, like, there could be a lot of these nuances, these subtle feedback that may actually have very distinct meaning or
Mm.
very special meaning. But I totally agree with you that we need more research, understand how it works or how the human system works.
Well, let's then finish on this. I really, really appreciate your time and like being so generous by sharing your experience and going into detail and in depth. I really, really appreciate it. And thank you so much.